This is precalculus notes on section 5.3e. And this notes is basically just to define a constant that in math we call E. It's a very important constant when it comes to a lot of phenomena in nature. And what you're going to see is that it's very applicable in the area of finance. There's an irrational number, we call it E. Irrational, just like pi is. It's a number that just happens a lot in lots of different types of math problems, just like pi does. It arises naturally in a variety of phenomena and plays a central role in the mathematical description of the physical universe. Okay, and here is how E is defined. Okay, E is defined, now this is a calculus concept, as the limit as n approaches infinity of 1 plus 1 over n to the power of n. Okay, now you don't have the calculus background to completely understand what limits mean, but I'm going to try and explain this to you right now in a way that makes it easy to understand. And so in the left-hand side of this table, what I have is just substituting some numbers into this equation for n. And I start out with a number that is the first counting number. I start with n equals 1. Let me pull up my calculator. Okay. Okay. So here's my calculator. I'm just going to go, first of all, 1 plus 1 over 1 to the power of 1. And that gives me 2. Okay. Now, in each subsequent problem in this table, my n is getting bigger and bigger and bigger slowly. So we're just going to analyze what happens. Maybe I shouldn't say slowly. It's getting bigger by a power of 10. But let's see what happens as n gets to be very, very big. So again, we'll do the same problem. 1 plus 1 over 10 to the power of 10. I get 2.5937. Okay. All right, same thing, but n equals 100. Oops, I messed that up. Let's start again. Oh, I messed it up again. Too many crickets. I'm wasting video time. All right, here we go. All right, so I've got, oh my God, turn now. One plus 1 over 100 to the power of 100. There we go. I think I finally got it. 2.705 or 48. 2.7048. All right, I'm going to keep going even if it kills me. 1 plus 1 over 1,000 to the power of 1,000. Okay. 2.7169. Okay, one more. 1 plus 1 over 10,000 to the power of 10,000 2.7181. Okay, so let's just take a look at what's happening here. As n gets bigger, the value of this formula isn't getting incredibly bigger. As a matter of fact, it seems to be narrowing down on a number that's somewhere between 2 and 3. And that's really key. It does approach a constant very quickly. Let's look at the next slide. Okay. So here I've got the calculator doing the work for me, and I've gone a little bit further than I did in my previous table. And we take a look down here at n equals 100,000, and then n equals 1 million, all right? And you see that to the significant digits of 4 places after the decimal, the value of that function is actually equal. I mean, it's still changing when it comes to 5, 6, or whatever places after the decimal, but to 4 places after the decimal, it stays the same no matter what n is, okay? So it doesn't take too much computation to see that this number is coming very closely to a constant. Okay. And so we call that constant E, all right? And now what we're going to do is we're going to go back to a word problem with interest. Suppose that you invest $1 at 100% annual interest compounded n times a year, okay? So if you just plug in the 1 for P, 1 for R, okay, and 1 for N. Oh, hold on. And we're not plugging in 1 for N. What we want to do is we want to consider that N is going to happen continuously. So in other words, instead of compounding every day or every hour or every minute, it's happening an infinite number of times per year, okay? So what happens is that this formula equals the same thing as this formula right here, okay? And so E is defined to be the number that we multiply by when we are compounding interest infinitely many times in any time period. All right, that's it for that video.